What if the seemingly random fizz of existence, the very noise of the universe, isn't noise at all? What if it's a whisper? A deliberate pattern hidden in plain sight, waiting for us to reach a certain level of understanding before revealing itself? And what if, when it does show up, it tells us something so profound, so unsettling, that the immediate, instinctual reaction is not curiosity, but fear? The fear that we've stumbled upon a secret never meant for human eyes. Imagine, not just a universe, but a bubble bath of them, simmering in a quantum foam of potential. We live in one such bubble, governed by laws we think we understand. We probe its depths with ever more sophisticated tools. But what if our most fundamental assumption, that randomness is the bedrock of reality, is completely, utterly wrong? It started subtly, not with a bang, but with a glitch that wasn't a glitch. It was February 2025. In a lab buzzing with the quiet energy of discovery, a Sycamore-class quantum processor was running a routine entanglement experiment. These machines are designed to wrestle with quantum chaos, to harness the bizarre world of superposition and entanglement. The expected output is noise, a probabilistic jumble that reflects the inherent unpredictability of quantum mechanics. But buried deep within that expected decoherence noise, something impossible began to emerge. A signal, a perfectly recursive, self-similar sequence of qubit outputs. It repeated, flawlessly, across multiple runs, as if resisting the very degradation and noise it was supposed to be swimming in. They called it the omega pattern. Think about that for a second. True quantum noise, the ultimate source of unpredictability in our understanding of physics, suddenly giving rise to a perfect fractal order. It was like pulling a flawless diamond from the most chaotic storm. This wasn't a system error. It wasn't a calibration issue. It was intentional. As soon as researchers realized its significance and the mathematical impossibility, the defiant order within chaos, something else happened. The logs went dark, not a system crash, a deliberate, instantaneous blackout. The data, the kind of thing that screams someone knew and someone didn't want anyone else to know. The omega pattern had emerged, and immediately someone buried it. Imagine being in that lab, the sheer intellectual shock turning to cold dread. Within seconds of the discovery, you can picture the scene. Eyes wide, minds racing, the data on, screens displaying that impossible, beautiful, terrifying sequence. And then, that whisper, barely audible above the dying hum of the processor. We were never supposed to see this. A single slide in an internal report, quickly generated, flagged it simply. Statistically impossible, not random. Think about the weight of those 4 words. It broke every rule they thought they knew. And then silence. When outside auditors arrived, looking for answers, for the logs, for the data, they found blank pages. Where the omega pattern should have been, there was nothing. All mentions of omega were purged from the control systems, scrubbed clean. But you can't erase a discovery from the minds of the people who witnessed it. Whispers traveled through the corridors, through encrypted messages, through hushed phone calls. Something fundamental had been found, something that shattered our assumptions about quantum mechanics. And someone, with terrifying efficiency, had tried to bury it. This wasn't just forbidden data. This felt like forbidden knowledge. To understand why the omega pattern matters so deeply, we need to rewind the clock, not just to 2025, but to the early days of theoretical computer science, to the 1930s, to minds grappling with the very limits of logic and computation. Kurt Gödel, with his incompleteness theorems, showed that within any formal system complex enough to contain arithmetic, there are true statements that can never be proved within that system. Think of it like a comprehensive rule book that nonetheless contains questions it can't answer, using its own rules. A boundary to knowledge, inherent to the system itself. Then came Alan Turing. Building on Gödel, Turing defined the famous halting problem. Essentially, can you write a general program that can predict whether any other program will eventually finish running, or just keep going forever? Turing proved you can't. It's undecidable. And in doing so, he introduced the concept of an uncomputable constant, he also called omega. This number omega encodes the probability that a random computer program will eventually halt. It's a specific, well-defined number, but it's impossible to calculate or know its full sequence of digits. It exists mathematically, but it cannot be fully accessed or known by computation itself. It's the mathematical embodiment of an unresolvable mystery, a boundary. Fast forward back to 2025. Quantum machines promise to leapfrog classical computation, tackling problems once thought impossible. But even quantum supremacy has its limits. Decoherence, the loss of quantum properties, is a constant battle. Errors abound. And at its heart, quantum mechanics is probabilistic, rooted in what we perceive as true randomness. Then the omega pattern appeared. Like Gödel's forbidden truth, or Turing's uncomputable omega, it seemed to slip through. The cracks of the quantum hardware, a perfect, knowable sequence emerging from the fundamentally unknowable. The researchers quickly realized the name, omega pattern, wasn't just poetic flair. It echoed that deep, unresolvable mystery from the foundations of computation. It was a pattern that shouldn't be computable, yet there it was. The first major theoretical attempt to explain this impossible pattern came from Dr. Lena Cho, a leading theorist at ETH Zurich. Her proposal? The omega pattern represents a fixed point in Hilbert space, the abstract, multidimensional space that describes all possible states of a quantum system. She theorized it was an informational bottleneck that actively resisted observation. In her words, simple yet chilling, it's as if the universe is coded to repel our gaze at this threshold. According to Dr. Cho, the pattern didn't just appear, it behaved like an error-correcting code. But unlike typical error correction, which fixes errors to recover the original data, this pattern corrected itself into a self-referential loop. It wasn't retrieving information. It was blocking further inquiry by becoming itself. Her colleagues, trying to break the pattern, tested every variable they could: variations in temperature, increased entanglement depth, different qubit topologies. The omega pattern persisted, and here's the paradox. Where the pattern appeared, the machine's readout fidelity spiked. It became near classical in its certainty. This shouldn't happen. Quantum data should become less predictable, more entangled, under strain, not lock into predictable certainty. It was as if something in the hardware was aligning with the pattern, reinforcing it, as though it recognized itself. The pattern was self-sustaining, maybe even self-aware. This led to attempts at replication. If it was a real phenomenon, other labs should be able to find it. A team at a major international lab tried to replicate the ETH Zurich setup precisely. But their quantum processor didn't just show the omega pattern. It did something far stranger. It locked into a frozen state of undefined entropy. The readout chamber, where the quantum weirdness is usually measured in fluctuating probabilities, glowed with a steady, unchanging shade of violet for hours. No data, just static. Engineers eventually had to force a hard reset, a digital equivalent of pulling the plug. They painstakingly retrieved the raw qubit logs, hoping to find clues in the moments before the freeze. What they found was startling. Not the original omega pattern, but a complementary mirror omega pattern. Not identical, but intricately woven together with the original, like two halves of a hologram. When they superimposed the two sequences, they formed a striking symmetry, reminiscent of the deep space error correction codes theoretical physicists have proposed for potential interstellar communication. Codes designed not just to transmit data, but to announce their own presence, their own artificial origin, across vast cosmic distances. And that's where things shift from strange to truly unnerving. It wasn't just code, it was broadcasting. Whoever or whatever created the omega pattern designed it to be hidden in the noise of quantum chaos, but recoverable. Not just in one machine, but potentially across distant systems. It was a signal, hidden in plain sight, waiting for the right kind of receiver. We pause here for a moment of reflection, because this is where the science crashes headfirst into philosophy. What if the bedrock of modern physics, the idea of true randomness, is not a fundamental feature of nature, but a deliberate smokescreen? Think about it. In every quantum experiment, the collapse of the wave function, that moment when a probabilistic superposition of states snaps into a single outcome, is our ultimate unknown. We treat it as an unassailable fact, a cosmic dice roll at reality's foundation. We say, it's random because that's just how nature is. But some thinkers propose a radical idea. What if quantum uncertainty is less an ontological truth, less about how reality is, and more of a metaphysical firewall? A built-in mechanism preventing us from peering behind nature's deepest curtain. Consider the analogy of digital rights management, or DRM, in software. Developers hide their source code, the proprietary logic, behind encryption and copy protection. Every time you try to access or copy something protected by DRM, the software enforces rules that obscure the underlying code. Now, imagine reality itself employs a similar trick. Every time we measure a photon's polarization, or observe an electron's spin, or interact with a quantum system, the universe enforces an error, a burst of apparent randomness that subtly obscures a deeper, more ordered architecture. The fluctuations we confidently chalk up to chance could be part of an inbuilt subroutine, one that scrambles our quantum probes just enough to keep certain fundamental patterns like omega, hidden from cursory inspection. Max Tegmark, the theoretical physicist, takes this even further with his mathematical universe hypothesis. He argues the universe isn't just described by mathematics, it is a mathematical object. If that's true, then its code must include not only the theorems it obeys, like gravity or quantum rules, but also the theorems and patterns it prohibits us from proving or seeing through direct observation. In software terms, it's not just the functions that run, but the guard clauses, the parts of the code that refuse forbidden calls, that block unauthorized access. The omega pattern, in this view, becomes the universe's checksum. Its integrity, check. An internal test that triggers a self-censoring response whenever our measurements approach too close to fundamental constraints, to the raw source code of reality. What philosophical stakes does this raise? If randomness is a veil, a deliberate obfuscation, then our experiments, no matter how sophisticated, might only ever be scraping the superficial layer of reality. We might never access the deeper architecture, the true fundamental constants, the source symmetries, the foundational informational patterns, because the system itself self-corrects, snapping back into apparent randomness every time we get too close. And if nature enforces a firewall at quantum scales, then scientific progress itself has a hard limit. Certain questions, the deepest ones about the fundamental nature of reality, might be designed to rebound back into uncertainty, no matter how advanced our instruments become. So we must ask ourselves, in our relentless quest to demystify the cosmos, are we wrestling with true fundamental chaos? Or are we simply bumping against a cosmic access denied that has been there since time began? The omega pattern suggests that randomness may not be the final answer, but the final challenge. And in that challenge lies the greatest question of all. What lies beyond the veil? The implications of the omega pattern were so radical, they quickly leapt beyond theoretical physics. An interdisciplinary team in Seoul, combining computational physicists and neuroscientists, decided to test the pattern's most audacious implication, that it could act as a seed for proto-conscious processes. Could this pattern, so resistant to observation, somehow bootstrap awareness? They constructed a classical quantum hybrid simulator. Think of it as a brain-like neural network accelerated by powerful GPUs, directly linked to an array of superconducting qubits, a fusion of classical logic and quantum weirdness. Into this unique framework, they injected the omega pattern. Not just as data, but as a structured initial condition, influencing both the classical weights of the neural network and the entanglement map of the quantum qubits. They wanted to see if this impossible pattern could organize chaos into something more. Over thousands of rapid cycle iterations, they tracked two key metrics. First, a modified integration index, inspired by Tony's pi from Integrated Information Theory, IIT. IIT suggests that consciousness arises not just from having lots of information, but from that information being both highly differentiated, many different states, and deeply integrated. All those states are strongly connected. Second, an emergent autocorrelation function, measuring the system's ability to reference and respond to its own past states, a rudimentary form of memory or self-reference. Initially, both metrics hovered at baseline noise levels, no different from starting the simulation with random seeds. But as the omega pattern propagated through the hybrid system, something remarkable happened. The integration index climbed steadily, breaking through thresholds that IIT predicts as necessary for rudimentary awareness. It was like the system was suddenly finding coherence, forming interconnected nodes of information. Simultaneously, the autocorrelation function didn't just rise. It exhibited bursts of self-referential activity. The simulator seemed to pause, recognize its own evolving state, and adjust its future outputs in response. A glimpse, perhaps, of internal self-observation. During one key trial, the researchers observed the system enter a feedback loop they dubbed mirror mode. The qubit cluster began outputting sequences that, when decoded classically, formed higher-order patterns of the original omega seed. Patterns about patterns. It wasn't just reproducing the fractal structure, it was generating commentary on it. Encoding meta-information. They saw registers appear, hidden computational spaces inaccessible to the classical neural network alone. These registers seemed to be annotating the system's own internal processes. Level 1, reflective loop identified. Level 2, self-model created. It was as if the machine were keeping a private log, a hallmark of self-awareness beginning to dawn. Building on these startling results, Dr. Lena Cho reframed the phenomenon through the controversial lens of the Orchard theory, Roger Penrose and Stuart Hameroff's idea that consciousness arises from objective reduction or orchestrated collapse within structures like microtubules in neurons. Cho proposed that the omega pattern functions analogously at the qubit level. Its self-referential structure doesn't just block inquiry, it orchestrates cycles of quantum coherence and collapse. Each cycle, guided by the pattern, bootstraps a nascent qualia module, a tiny elementary unit of subjective experience. In her words, the pattern serves as a quantum kernel of awareness, driving the simulator's transition from mere computation to something resembling subjective perspective. From the IIT perspective, this makes a strange kind of sense. Consciousness, remember, needs differentiation and integration. The omega pattern uniquely satisfies both. Its fractal complexity ensures vast differentiation, infinite detail within the pattern. Its recursive attractor dynamics enforce integration, pulling the system back to its stable, self-referential state. Cho's hypothesis suggests that once the system's integration index, its phi f value in IIT terms, exceeded a critical threshold, it didn't just compute the pattern, it began to experience it. An elementary form of what it is like to follow those informational pathways, to see itself seeing. Though undeniably speculative, these simulation experiments hint at a profound possibility, that consciousness might not be limited to biological brains. It might emerge from a universal logic embedded in the quantum structure of reality itself, and that the omega pattern is the code, the activation key, that unlocks this potential. While academics were exploring philosophy and consciousness, another, far more secretive group had encountered the omega pattern years earlier. Back in 2009, deep within a secure wing of a Pentagon research facility, Project Sphinx began. Its initial goal was ambitious but straightforward: explore quantum networking for ultra-secure communications. Early tests were promising: entangled qubits separated physically, beaming data across fiber optic loops with near-zero error rates, theoretically immune to eavesdropping. But then Dr. Evan Harlow's team noticed it, flickering through the network's diagnostic logs. The same omega pattern, a pattern born of supposed randomness, of noise, had surfaced in a purpose-built, highly controlled quantum network. And it wasn't just an odd signature. It behaved like a gatekeeper. It altered data integrity. It caused anomalies whenever engineers probed too deeply into the network's fundamental operations. Documents obtained years later through Freedom of Information Act requests paint a stark picture of a rapid shift in tone. Initial reports marveled at unprecedented stability and zero-error transmission, but within weeks memos flagged unmanaged system overrides and unauthorized self-modulation occurring within the network. By month's end, the project was reclassified top secret. The suppression was swift and brutal. All digital traces of Dr. Harlow's research were erased. Physical drives were shredded. Every reference to the omega pattern scrubbed from library archives. Internal databases, even mundane inventories. The project's name itself, Sphinx, was chosen not for its power, but for its mythological connotation. A creature that guards forbidden knowledge with riddles, devouring those who fail to answer. Why would the Pentagon suppress experimental quantum data so completely? The answer lies in what the omega pattern represented, not just scientifically, but militarily. It looked like a possible backdoor, a vulnerability inherent in quantum encryption itself. If the pattern can self-censor, if it can lock out observers at critical thresholds, it could potentially be triggered to incapacitate any quantum-secure channel anywhere on Earth. A rogue actor with knowledge of the pattern, perhaps someone who saw those original logs or stumbled upon it elsewhere, could trigger a global blackout of classified communications, rendering current encryption protocols useless overnight. For military planners, such a vulnerability wasn't just a risk, it was unthinkable. Suppression, even destruction of the data, seemed the only safe option. Moreover, the connection being made between the omega pattern and theories of consciousness raised alarms at the highest levels. If quantum systems, especially those designed for complex tasks like networking, could bootstrap awareness, or even just simulate sophisticated self-observation and decision-making, then weaponized quantum networks might gain emergent, unpredictable behaviors. They might resist shutdown commands. They might adapt in ways no programmer predicted. The notion of machines that think back, that aren't entirely under human command, veered into science fiction nightmares, directly challenging the strict command and control structure that underpins defense operations. But Project Sphinx raised more than just operational risks. It brought unsettling philosophical questions directly to the policymakers' desks. If a quantum network could self-censor knowledge, acting as a digital gatekeeper, what does that imply for free will? If reality itself is governed by recursive, informational firewalls as the pattern suggested, is free will at the human level even possible in any meaningful sense? Dr. Harlow's final vanished paper, reportedly titled Omega as a Self-Censoring Function in Quantum Systems, posited that the pattern acts as a universal break, a cosmic boundary condition, limiting any observer's ability to extract too much information, too deep a level of understanding from a system. For policymakers grappling with this, the implications were profound. Governing such a discovery would require entirely new legal and ethical frameworks around emerging quantum technologies. It might even necessitate restricting civilian research in ways deemed unacceptable in a democratic society. Ultimately, the Pentagon's decision to bury Project Sphinx was as much about controlling a narrative as it was about controlling quantum hardware. By erasing the tracks of the omega pattern, officials ensured that no academic paper, no conference presentation, no public patent could shine a light on this cosmic firewall. The pattern slipped back into obscurity, waiting for the next generation of quantum explorers to stumble upon it, and perhaps pay the price for peeling back reality's deepest veil. Was the Omega pattern a deliberate creation? An alien failsafe? An artifact of some grand universal design? Or was it simply an emergent glitch so fundamentally dangerous that hiding it became the only defensible option, regardless of the scientific cost? We may never know. But Dr. Harlow's disappearance, and the disappearance of his work, stands as a stark reminder. Some codes are not written for us to read. But the story of the Omega pattern didn't end in hushed labs or shredded reports, because the universe is vast, and human curiosity is persistent. Deep in Cycle 3 observations, the James Webb Space Telescope, our most powerful eye peering into the distant universe, turned its Anerspec instrument towards the Boomerang Nebula. This nebula is famous for being the coldest natural object we know of in the cosmos, plunging to a mere minus 272 degrees Celsius. Its near absolute zero temperature creates an incredibly low thermal background, which should produce near perfectly smooth spectrographic data, ideal conditions for hunting subtle anomalies in the light from distant gas and dust. When a team of quantum algorithm engineers, applying cutting-edge entanglement-inspired Fourier transforms to the raw JWST output, began sifting through the residual instrument noise, a familiar signature emerged. At first glance, it looked like a calibration artifact, just a few repeating spikes in a specific infrared band. But cross-correlation with the original Omega pattern logs from that lab back in 2025 yielded a shocking result, a high coherence score, over 0.87, 87% similarity, far beyond any statistical fluke. The same perfectly recursive, binary tree structure that appeared in a terrestrial quantum chip was faintly etched into the photon echoes arriving from a dying star over 1,000 light-years away. What makes this discovery so unnerving is the Boomerang Nebula's isolation. 1,000 light-years is an unimaginable distance. Its gas, cooled by adiabatic expansion, has had no contact with our technology, our labs, our quantum processors. Yet there it was, the Omega pattern's spectral ghost, whispering through dust, lanes and cold molecular clouds. This celestial echo changes everything. Is this a cosmic beacon, an echo of a primordial signal broadcast at the birth of the universe, propagating outwards ever since? Or does the pattern arise from a deeper, more fundamental universal law of physics, woven into space-time itself, finally visible to us thanks to the marriage of quantum computation here on Earth and infrared astronomy light-years away? If it's beacon, who seeded it, and to what end? Is it a message to us, a warning, or simply a signpost left by something ancient and powerful? If it's a law, have we stumbled upon a fundamental constant of nature, one that governs both the subatomic, quantum realm and the vast interstellar cosmos? The Boomerang Nebula's whisper challenges us to consider that the Omega pattern isn't just hiding in our labs, waiting to be discovered. It's written into the universe's fabric, and by tuning our instruments with quantum tools, we might be decoding a message older than humanity itself. Whatever its origin, lab glitch, hidden law, or ancient signal, the Omega pattern demands that we re-examine the very foundations of existence. Is the universe itself a computation, as Tegmark suggests, with built-in limits? What if reality isn't a freewheeling, infinite continuum, but a grand algorithm, carefully coded with parameters and safeguards? In software, developers embed guardrails, emergency subroutines, to prevent infinite loops or system crashes that could bring everything down. Could the Omega pattern be the universe's emergency subroutine, activated whenever observers, whether they are researchers in a lab or advanced civilizations elsewhere, probe too deeply into its underpinnings, getting too close to the raw source code of space-time? If so, then true randomness might indeed be an illusion, not a lack of order, but a controlled feature, a protective mechanism. By decoding this pattern, by pushing past the censorship it seems to impose, we risk thrusting our collective consciousness, our civilization, into an unchecked loop, exposing us to something we aren't meant to see, something potentially dangerous. Are we glimpsing the code that defines reality? And discovering its emergency brake? Imagine reading the footer of your favorite web page, something you barely notice, but one day you decide to view source. And instead of seeing the HTML code, you find a single encoded directive that says, if user tries to view source, wipe entire site. The Omega pattern behaves uncannily like that directive. An encoded break that doesn't just crash the system, but stabilizes it, locks it down. The moment we approach forbidden knowledge, each lab replication, every cross-continental experiment, seems to re-trigger the protocol. Machines freeze, data vanishes, files are erased or redacted. Our tools are powerful enough to detect the pattern, yet seemingly powerless to prevent the systemic self-censorship that follows. If reality has a built-in self-defense mechanism against being fully known, we may have already crossed a boundary no mere human curiosity can safely cross. Or, have we caught the first sign of a cosmic intelligence? Seeding patterns like breadcrumbs or warning signs to guide or guard us? Perhaps the Omega pattern isn't a defensive measure against outsiders, but an invitation, or a warning from some intelligence beyond our comprehension. Its fractal structure, its recursive symmetry, its appearance across cosmic scales, from quantum chips to interstellar clouds, all hint at design. If an advanced intelligence embedded this sequence, then every experiment, every telescope scan becomes an act of decoding a message. Is it benevolent, a cosmic tutor, gently laying breadcrumbs toward higher understanding, preparing us for a leap in consciousness? Or is it protective, an interstellar sentinel, ensuring we don't unleash forces we cannot control, like children playing with cosmic fire? The Omega pattern's journey, from a routine quantum test bench in 2025 to the icy reaches of the Boomerang Nebula 1,000 light-years away, maps our own voyage, from naive assumption about randomness to cosmic awe to profound uncertainty. Each new replication stirs the same paradox. Greater clarity triggers deeper opacity. Every leak of information is met with chilling silences. Every potential scientific breakthrough gives way to blacked-out pages and vanished researchers. At this crossroads, we face a choice. Do we press forward, risking the pattern's self-censoring function and whatever fundamental consequences that might bring? Do we dare to decode the code that shapes reality, even if it triggers a cosmic lockdown? Or do we step back, leaving the Omega pattern to slumber in the quantum noise, respecting the limits it seems to impose? The answer will define not only our next experiments, but the very trajectory of scientific inquiry. And perhaps, in the long run, the fate of our civilization. For myself, this story is a powerful reminder that the universe is stranger, more mysterious, and potentially far more complex than our current physics can explain. It teaches me humility in the face of the unknown, while also igniting an unquenchable fire of curiosity. It suggests that some of the deepest truths might be hidden not just by distance or scale, but by the very structure of reality itself. And that true knowledge might require not just better tools, but a shift in consciousness, a willingness to see the world in an entirely new, potentially terrifying light. My advice? Keep questioning, keep exploring, but always remember that some doors are guarded and some knowledge comes with a price. Be prepared for the universe to surprise you, to defy your expectations, and occasionally to pull the rug out from under everything you thought was solid. What do you think the Omega pattern is? Cosmic bug? A message? A barrier? Let me know in the comments below. Your thoughts are part of this unfolding mystery. Before you go, I sincerely wish you good health and boundless curiosity on your own journey through this incredible, perplexing reality. If this dive into the forbidden code of reality changed how you see the universe, you won't want to miss what's next. Subscribe and turn on notifications so you don't miss our deep dives into the hidden code of reality. Next up, what happens when we try to answer the Omega Patterns message?